Okay, now we're going to tackle something that's called piecewise function. It's because you have one function that is broken into two pieces. So look at what we have. We have this and we have that. The first one, f of x is equal to x or y is equal to x. Well, that is just a linear equation. If x is 0, y is 0. If x is 1, y is 1. X is 2, you get the idea. And it goes on and on. This direction, right? Let me see. Anyway, and then we have this second piece. Well, I'm not quite finished with that because we then have to discuss the domain restriction. I'm just showing you what the original graph would be. And then we have f of x, I should have done that in a different color, is equal to negative 1x plus 2. So you'd start up here at positive 2, go down 1 over 1, down 1 over 1, and then that would be the graph of that equation. It would just go on and on and on, right? Except for that, in piecewise functions, I'm going to go ahead and erase what I just did. In piecewise functions, the really important piece to understand, and some of you that will end up taking calculus, this ends up being very helpful information, is this tells us that we can only look at where the x values are negative 4 for this graph, for that original linear equation, the one that looked like this. Except for I think I had that in blue. Where x is negative 4, we can only look at it from this point, from this point going further. We can't even look at this piece. So that goes away. And then the other graph that originally did something like this, still going to move it until it gets to negative 4. And there we have it. We have those two graphs with the given domain restriction. And this gap right here is called discontinuity, but both of those graphs are part of the original function. This function is just split up into two pieces. And I'm going to show you one more. So this time we have a quadratic graph, and its original, if we just put the parent graph up there, it would look like this, although what's the opposite of positive 2? Negative 2. So it is transformed to this way. If we didn't have a domain restriction, that's what that graph would look like. But because the only piece we can look at is from, and that's a less than, so there would be a hollow dot there and the line would go that way. So the only part of that graph that we can look at is this piece right here. Let me go ahead and the other part we can't even look at. We would just have to ignore that. Okay, and then we've got this second piece, this horizontal line. Well, normally a horizontal line at 3 would look like this. But again, the restriction is we can only look at wherever the x value is negative 2. So the only part of that line that we can look at, and because that's a solid line right there, there would be a solid dot. For this one, that's a hollow dot. For this one, there's a solid dot, and that gap is a discontinuity. All right, that's it for piecewise. Keep in mind they get sometimes can be more complex. Sometimes you'll have 3 systems, possibly even not 3 systems, three three parts or maybe 4 parts. But this is just the gist of how to graph piecewise functions.